Hello everyone, welcome back to Quotient. So today we are going to study proof of our quotient and chain rule. So first we'll be proving the quotient rule. So it should be a piece of cake for now. So you should be able to solve this directly. So let's see what we are going to solve. So let's say we have a function hx, which is your fx by gx. So if you remember, we have already proved two of the rules, which are your reciprocal rule, and second one is your product rule. We proved this product rule in the last lecture, and we proved our reciprocal rule before this. So we have this fx and gx. So obviously with the product rule you can and with the reciprocal rule you can just directly prove this as well. So let's say I want s dash x. So you know what limit is: limit of delta x tending to 0 for h x plus delta x minus hx divided by your let's say delta x. And you know what product rule was. So let me first write the reciprocal rule. So reciprocal rule was basically your 1 by gx. If you want to find the derivative of this, then we just have your g dash x divided by gx whole square, and obviously a minus sign over here. So minus of this, so negative of this. So you have this as your reciprocal rule, and for the product rule you have your product rule. So for the product rule you have your d of fx times gx divided by dx equals to, basically this was limit. So you already know what your functions derivative are. So obviously if the limit exists, then the derivative exists for fx gs and whatever your complete function is. So yes, so for this we had this product rule proved, which was, I think, your it was f dash x times gx plus fx times g dash x divided by your so basically this was your complete one. So there was nothing else, I think. Yes, we can always prove this again and again, but remember this so that we can so that we don't have any problem in the future yet. I mean, we don't get any problem in the future. So you are not going to prove them again and again. So once you have remembered them, you can just use them to prove something else. So that's how math has been going right now. So let's prove the quotient rule now. So quotient rule. So you have your fx by gx. We can assign this as fx divided by times 1 by gx. So now you have two functions, fx and 1 by gx. So let's call this as fx times zx. So zx is basically your 1 by gx. So for, obviously you know the product rule. So you can just write h dash x equals your let me write this as hx, and then this is your hx for now. So you have your f dash x, which is basically your derivative of fx. Then you have your zx, which is basically 1 by gx. So, or I can just directly write zx as 1 by gx over here. Or let's write this as zx only. So you have this f dash x times zx minus plus fx times z dash x. So this will be your derivative of hx for the new quotient rule which we are going to find. So this will be your f dash x divided by gx plus your fx times derivative of your 1 by gx. So now you already know what your derivative of 1 by gx was. I think you know that by this reciprocal rule. So let's say you have your f dash x by gx plus fx times your you can directly write it over here, g dash x divided by gx square. Now what you can do, Okay, so this will be minus sign over here. So let's say we have this minus of this. Okay, so let me write it again. So we have this minus of gx divided by your g dash x. Sorry, minus of g dash x divided by your gx whole square. So you can write this in a bracket. Then once you solve this, you'll get fx times gx. Basically, this was a single gx and this was gx square. So you get this. And this minus symbol, you can just take it over here. And then you can write it as gx dot f dash x divided by your gx whole square. So basically, conditions are the most important thing in your maths. At what condition or at what for what set it applies, this formula is valid or anything. So you don't just have to learn the formula, you have to also remember for what or for what conditions it is valid. So you have to like this is the golden rule. Learn conditions along with formula. Learn conditions along with formula. So you have to learn the condition for those formula as well. So this is the golden rule, I would say. So let's say we have so we already proved now what our quotient rule was. So this will be your quotient rule. So let me write it neat and clean. Suppose you have f and then this, then d by dx. Well, obviously we didn't use limits because we already had the formula. I mean, previous formulas were there to prove this. So you have this, then you can just write it as f dash x gx minus of your fx times g dash x divided by gx whole square. So you have to remember that this upon symbol gives a minus sign. Basically, if you want to remember it from the product rule, otherwise you can just remember this complete f dash x gx minus fx times g dash x. So one which has the denominator gets the minus sign and the denominator gets the square. So you have that. Next, you can just prove your chain rule. Obviously, proving the chain rule would be much more difficult than this. Actually, it wasn't difficult at all, I would say, because we just implemented what we knew. So we didn't actually prove anything. It was just like solving it directly without thinking much. So next we have your chain rule. So let me check in how much time we proved that. So we proved that under, I think, 6-7 minutes. So this is the chain rule. So what you can do, you can just write it over here that chain rule is valid for composition functions. Basically, you don't have to remember what composition means. Basically, f of g of x is your f of g of x. So you can read it as f of g of x, which is basically your function of gx. So you just replace x by gx inside fx to get this f of g of x. And what is actually your chain rule? So you write it as f of g of x. So basically derivative of this is equals to f of g of x times your g dash x. So why do we get this extra function over here? Why this g dash x? Why not directly this? So for that, you can just think it in that way, that when we proved that while we were proving that x to the power p by q is equal to y, and then we just proved that x to the power p equals y to the power p q. We just at that time we directly said just because y is moving continuously with respect to x, so we can say that y will also get differentiated. So it's just the same pattern that this we get this extra gx g dash x, sorry. So by the way, we are going to prove this, not just say that by intuition. So now let's begin with the proof. So at first I thought, why don't we prove it for polynomial, then we can prove it for other functions as well, but that would be like doing it for 4 times or 5 times. So we won't be doing it that way. Instead, we will be just solving directly. So first you have this f of g of x, correct? Then you have your hx, hx equals to your f of g of x. Then you can say h dash x equals to your limit delta x tending to 0, where x plus delta x minus hx divided by delta x is your derivative of hx. Then you can say that limit delta x tending to 0, f of, basically you have this f of g of x, then you can say that f of g of x plus delta x minus of fx divided by your delta x, you have this f of g of x over here. So you will have this. So now from here you might be stuck that what do we have to do. So at first, if you try to think carefully, then you can see that this itself f of gx plus delta x and gx is there. So we need something below g of x plus delta x minus g of x in the denominator, so that we can just write it completely as f dash x or f dash gx. So to write it like this, since I've already given you that there is f dash of gx, so to write this, you just need something in the denominator, something like this. So most of the problem now might get solved after listening what I've said. So you must be able to solve it now. So let me just write what I've said. Limit of delta x tending to 0. We can obviously multiply both things by 1. And let's say that 1 is your g of x plus delta x minus g of x by g of x plus delta x minus g of x. So with this, you can say f of g of x plus delta x minus f of g of x divided by your g of x plus delta x minus gx times, obviously you can replace them by taking this over here and delta x over there. Basically you are rearranging, you are arranging that in such a way that it gets solved for your both the equations. Now since you know that these equations are continuous, not equations, these expressions are continuous for your equation whichever you will be holding. So since they are continuous, so that means they are also differentiable. So now we can say, since fx and gx are continuous, this implies that they are differentiable. F dash x and g dash x exists for them. So what you can do, you can just write limit delta x tending to 0 and this part over here. So let's call it u, and then you can write limit delta x tending to 0. Then this part over here, let's call it v. So this as v and this as u. So you have this limit x tending to 0 because u and v were continuous. Sorry, not u and v, because fx and gx were continuous. So their functions which we are going to find their limit, their derivatives exist. So we can just write them separately. So that's what our intuition and thinking was to get over here. So next, you already know what it will look like, u dash and v dash. So let's calculate what u dash and v dash will look like. If you see it carefully, then you can just see that it will look like this times g dash x. So now you know h dash x for if hx equals to your f of g of x, obviously you can write this like this as well, f dash o g, sorry, not o, this is basically your symbol for what do we say that for the composite functions you write this symbol. Next you have your x, then you have this g dash x. So f of g of x. So if this was your function, then you can write h dash x was basically your f dash o, basically composite of g x times g dash x. So this you'll get as your result of the derivative rule, which is your chain rule. So now we have covered this product rule. Okay, so before that we have also covered that what do you say? We have covered few rules, reciprocal rule, and we have this product rule, quotient rule. Then we also have your chain rule, and we have also proved our x to the power n derivative equals to your x to the power n minus 1, n times x to the power n minus 1. So it equals to this for all x belonging to basically we have only proved it till your what do we say, for your rational numbers. So we are going to also prove that for irrational numbers and all. So we haven't yet proved that x belongs to real number for this. So wait for few more days, not few more days, just few more lectures. We are going to prove that as well. So on the next Tuesday, you are going to have a fun session, I would say. We'll be actually using Python over there, so don't worry about that. So we'll be explicitly using this matplotlib to basically draw a car. On Tuesday. I think the date would be it would be around like 11 or 12 or maybe 10. I mean 10/11. Based on your timeline, it will be like 10 or 11 at the time of upload. So 10 or 11 of your this August 2026, you are going to have a fun session. Basically, we'll be drawing a car using matplotlib. Basically, you will be using equations. Will be used. Equations will be used to animate a car. Same logic which we use in game development. Not basically game development, but even when you are like developing an engine, you will be using the same thing. So thank you everyone. Thank you for watching. We'll be meeting tomorrow. So let's wait for Tuesday. Sorry, not Tuesday. Wait for Sunday for the next lecture, and for the fun lecture, you have to wait for Tuesday. Wait till Tuesday. Thank you everyone. Thank you for watching.